Good evening. Okay, right? Okay, everything okay. Okay, today our first task, 2000, what is this paper? 2020 structured question number 4. It's a very simple question based on force and friction force, especially friction force, and some work energy part as well. Okay, let's start. Before that, tomorrow morning you have an exam. You have only, it's a very simple exam. You have only 2 essay questions. 2 essay questions. The first question based on Dilit. Why are you absent today? Dilit exam ke hiti nahi. Others, everyone is there, right? Yeah, online students, your exam will be held tomorrow morning. Ada physical la liyala inni. Dilit, why absent? Send me message. Yeah, you have only 2 essay questions. The first question based on coordinate geometry and area volume. Very simple. Coordinate geometry and area volume. But the thing, very carefully you have to answer for these questions. And a lot of thinking parts. That's why you have 1.5 hours only for 2 essay questions. You have 45 minutes per 1 essay question. You have to be very careful. Very careful. I hope to give some help during the exam, and the thing I will explain tomorrow morning. You have to be very careful. The second question based on force, work energy, power, and related things. Force and work energy, power mean. Force and work energy, power. Yeah, it's a mixed question. Mix and yeah, moment of force, everything application question. Hi. Okay, as a practice, let's discuss this force question first. Hi. The following graph show the variation of the friction force with the force applied on an object. Okay, the y-axis is a friction force. This is 2020 structured question number 4, right? And the y-axis is the friction force. The x-axis is the applied force, right? Okay, this is the graph, shape of the graph. Which segment of the graph present each of the following? Okay, now you know, if we apply a force on any object, now it is a rough surface. This surface is a rough surface. Okay, if I apply a force, think now it is 2 kilogram object. If I apply 5 Newton force, 5 Newton force. Now think the limiting friction force of the surface. Normally, I think you can remember friction force mainly three types. What are the types? Static friction force, limiting friction force, and dynamic friction force, right? Okay. Now think the limiting friction force mainly depend on the surface type. I think you can remember. Limiting friction force depends on the surface type. If you got a rough surface, its limiting friction force is a greater value. If you got a tile surface like a smooth surface, its limiting friction force is a low value, right? Now think the limiting friction force of this particular surface 20 Newton. 20 Newton is a limiting friction force. Okay, if I apply 5 Newton external force on this object, is it moving or not? Is it moving? මෙයා move වෙනවද? Okay, Dilith. Can you do it online tomorrow? හෙට කරනවද? No, it's not moving. Not moving because 5 Newton, what is the friction force? What is the friction force act on this object? 5 Newton. Now it is balanced. Due to this balance condition, the object is still rest. If I apply increase this force up to 10 Newton, no problem. The friction force also getting 10 Newton. Friction force also getting 10 Newton and no movements. Still rest. Still in the rest. If I increase up to 15, friction force increase up to 15 Newton, balance and no any movements. Still rest. If I increase up to 20, external force up to 20 Newton, what happened? What is the friction force? Friction force 20. Still object not moving. Still rest. Still in the rest. If I increase up to 21 Newton, what do you think? I'm going to apply 21 Newton on the external force on this object. 21 Newton external force on this object. Okay, what do you think the friction force? Is it 20 or greater than 20 or less than 20? Vihanga, it is 20 greater than 20 or less than 20. With me? The friction force 20 or greater than 20 or less than 20. Yeah. Wait, it is less than 20. The friction force less than 20 act on this object. I think it is 18 Newton. 18 again, less than 20. Okay, if I apply 25 Newton on this object, what's the friction force? What's the friction force? You may. If I apply 25 Newton, what is the friction force? Yes, it is again same, constant. After limiting friction force, actually the dynamic friction force now at this rest condition, when me rest at rest, when this object, the force increasing, and while object rest up to this level, we called as static friction force. Static friction force because object is rest. When increase the external force, the friction force also getting same value, balancing. Therefore, the object is still rest, that we called as static friction force. The maximum friction force that can given by any surface that we called as a limiting friction force. I think you can remember. I told at this limiting friction force, object is not moving, but it is try to start moving. It is a maximum friction force. The limiting friction force is a maximum friction force that can be given by any surface. Remember, maximum, maximum. After maximum friction force, what happened if we increase the force up more than limiting friction force? The object is start to moving. Object is start to moving. Sorry, object starts to moving. But remember, the the dynamic friction force little bit less than the limiting friction force, and it is a constant value. After limiting friction force, the dynamic friction force is a constant, same value. Okay, that's the story. Now you can answer. Okay, these values, if you got into this applied force and friction force into graph, okay, this is the shape of the graph. This is the shape of the graph. Okay, which segment of the graph represents the each of following force? The dynamic friction force. What is the section? Then you answer. Dynamic friction force, C, D. Good. C, D. The static friction force. Static friction force, A, B. Good. What is the mean by limiting friction force? Okay, how we can define the limiting friction force? The maximum friction force. The maximum friction force. This maximum word compulsory. The maximum friction force by any surface. Any surface. Called as the limiting friction force. Called as a limiting friction force. At that moment, the object try to start moving, but it is still not moving. Limiting friction force එකෙදිත් move වෙන්නේ නැහැ. හරි. Okay. Which point represents the limiting friction force on the graph? Yeah, what is the point? What is the point? What's the point? B. Great. B. B is the point. B is the point. Hard. Next one. A person pulls a box of 50 kilogram along a frictionless horizontal floor. Frictionless means no friction, smooth surface, right? Horizontal floor using a non-extendable light rope. Non-extendable. What's the meaning of non-extendable? Non-extendable means when we apply force, it's not it don't have an extension, not increasing the length, right? Not increasing the length, same length. And lightweight. Light mean we don't need to worry about weight of the string. Weight of the string. Lightweight. Rope which is inclined at an upward angle of 30 Newton, right? Which is horizontal in as shown in the figure. The person exerts a constant force of magnitude 300 Newton. Yes, 300 Newton magnitude on the rope. Consider sin 30 equals 0.5 and cos 30 equals 0.87. Right? Mark on the above figure the normal reaction and the gravitational force acting on the box. Okay. How we can mark the normal reaction? Normal reaction means perpendicular reaction, right? Okay. Perpendicular reaction always, no, perpendicular reaction always perpendicular to the surface, remember. Always perpendicular to the surface. And the gravitational force. What's the meaning of gravitational force? The force towards to the gravity. That is a weight. Weight. This is a weight. This is a weight. You have to remember these 2 points. Always the weight act towards to the gravity. Act towards to the gravity. Gravity එකට තමයි තියෙන්නේ. But perpendicular reaction always perpendicular to the surface. Remember, perpendicular to the surface. That's very important. Mark on the above figure. That's an okay. Calculate the acceleration of the box. Okay. Now it is a frictionless surface, right? Can you calculate? I can give you 1 minute. Acceleration. Others? Only 2. The acceleration of the box. The acceleration of the box. Okay, how to get the acceleration? Acceleration, it is, if it is accelerate, it is Newton's second law, right? Newton's second law, because it has an unbalanced force. Okay, now what is the unbalanced force? Now F equal, according to Newton's second law, F equal ma is the equation. The unbalanced force towards to the motion 300 cos 30. The cos 30 value already given. Cos 30 value already given. 300 cos 30 mean cos 30 cos 30 equal the mass of the object 50. Don't know acceleration, right? Cos 30 value already given 0.87. 0.87 equal 50A. Now what is this? 300 into 0.87? What is value? $87. 261. A equal 261 divided by 50. 261 divided by 50. It is 5.22. 261 divided by 50 equal 5.22 ms minus 2. ms minus 2. met me, what is a 6 කියලා තියෙන්නේ. No, Dinal, no problem. Yeah. This is not the accelerate direction. It is accelerate to horizontal direction. Yeah, that we call as force resolution. I think you know. That we call as force resolution. Into angle direction cos theta. If it is opposite other direction, it is sin theta. Okay, try to say third one. Calculate the work done by the applied force when the box is moved by 2 meter. 2 meter displacement. The work done by the object is asked. You met Vihaga? Adarane? Vihaga, this is 2020 past paper, structured dissection number 4. Final structured dissection. I got printouts, past paper printouts. ඒ ටික හදාගන්න. Past papers ටිකේ මේ printout එක ගන්න. No need mark schemes, only past papers. Now you have 2015 to 2025. You have 11 papers. Still you don't have 25 paper. Okay. Okay, I will collect that from Isurupa. I will collect and send you. Vihanga, could you find? Pagattadu? Calculate the work done by the applied force when it is moving 2 meter distance, 2 meter displacement. Yeah. Okay, the work equal, I think you can remember the equation. Work equal, what is the equation? Applied force multiplied by the displacement into force direction. Always the rule is the force applied direction and displaced direction should be same, right? But in the diagram, the displaced direction and force applied direction, it's not same. You have to resolve. Therefore, this resolution is compulsory. 300 cos 30 again. 300 cos 30, you don't need to multiply again. It is 300 into 0.87 cos 30 multiplied by 2 meter. It's Newton. 600 into 0.87, it is 522 joules. 522 joules. Joules and unit joules work. Joule. Final one. Consider that the above box is pulled with a light metal wire. Light metal wire. If the metal wire is exerted by 2 millimeter due to the applied force of 300 Newton, calculate the elastic potential energy stored on this wire. Simple. The elastic potential energy is asked. Okay, what is the equation? The elastic potential energy, we have two equations, no? We have two equations, half into Fe and half Ke square. Half into Fe and half Ke square. Yes, half Fe we can use. Half Fe because applied force and extension already given. Very simple. Half the applied force 300. 300 to 300 cos 30. That's my problem. That's my doubt. 300 to 300 cos 30. Dole, what do you think? 300 or 300 cos 30? 300, yes. Why? The force applied in inclined direction, it's no problem. 300 is applied force. No need to resolve it. The extension 2 millimeter. Can you substitute in millimeters? No. 2 divided by 1000 to convert into meter. To convert into meter. 20 to 20 cancel. 2 to 2 cancel. 3 over 10. 0.3 joules. 0.3 joules. Now, Dinu, how you got 300? ඔයා මිලිමීටර්ස් වලින් දාලා තියෙන්නේ. Okay. Sorry. My bad. Why don't we use cos 30 here? Why we need to use? ඇයි අපි use කරන්න ඕනේ? See? In work calculation, the work in the work equation, why we use? Because work equal force into displacement into force direction. Force and displacement compulsory to have in same direction, right? But in the force 300 applied on this string, this direction, make a direction එක අපිට energy එකට මේ එච්චර ඒ කියන්නේ energy එක it's a scale, therefore direction is doesn't matter. This moving direction එක ඕනේ නැහැ. Okay, this is 2020 question. Let's move into essay part. It's electricity questions still we can't, no? This one. This is our next task. 2021, question number 9. Question number 9, part AB from Bernoulli's theorem, but part C is a good practice. On the practice question, it is from mechanical properties of matters. And make up a karad class again. They don't. Not discussed, right? I didn't discuss. Okay, next Saturday, let's move into, let's start to discuss area volume essay question. I put in the group to practice. Okay, then let's discuss. Okay, next week, now a lot of physics part covered. අපිට මේ ගොඩක් questions තියෙන්නේ මේ industry chemistry and electricity lessons and heat. Until cover them, we can't discuss them, right? Until cover this advanced lessons, next week let's do area volume essay questions. ගොඩක් තියෙනවා. Yes. Okay. The figure show this type questions make them godak lot of details, no? We eight rules. So like a paragraph, no? Lot of details. Okay, the first thing you have to understand, you have to imagine this story within one reading time. If you have to read 2 to 3 times, make a detun parak kiwannot, you have to spend more time. The thing you have to understand this within one attempt. The figure show a setup used for measuring the tensile force of the kite string which is vertical. Okay, this is a kite string, right? This is a kite string. Here a rubber string of 40 centimeter. Length 40 centimeter. මෙයා තමයි rubber string. This is a rubber string. The width, length 40 centimeter. This is 40 centimeter. It is given. Length 40 centimeter and width 2 centimeter. Width කියන්නේ මෙයා. It's also everything given. Width 2 centimeter and it has 2 millimeter thickness. Make a mavagan, it's a just rubber string. Rubber string කියන්නේ මේ වගේ එකක්. It's not a rubber rod. String එකක් කියන්නේ පටියක්. It's just like this. Like a patiyak. The height 40 millimeter, the length and width 2 centimeters, and the thickness, thickness 2 millimeters, right? These are rubber string. These are මේ වගේ පටියක්. හරිනේ. නිකන් අර tube එක පටියක් වගේ. හරි. is attached firmly to the kite string at the top and to the ground at the bottom. Right? දැන් මොකද කරලා තියෙන්නේ? රබර් පටියක් අරගෙන ඒක මෙහෙම මේ ක්ලෑම්ප් කරලා ඒකේ kite string එක ගැට ගහලා තියෙනවා නේද? An indicator running on the vertical linear scale is attached to the upper end of the rubber string. An indicator running on the vertical linear scale. Yes. This is an indicator. Indicator means just arrow mark, right? Arrow එකක් set කරලා තියෙනවා. Indicator and linear scale attached for the measurement. Take measurement. Okay, this is stored. You have to understand. Okay, what is the use of the indicator and the scale of the setup? What is the use of the indicator and the scale of the setup? Okay, what is the use? What's the purpose of adding indicator? Yeah, then you have to explain. If we not use indicator, මේ වගේ arrow එකක් use කරේ නැත්තම් මොකද වෙන්නේ? It's coming measurement errors according to the දැන් අපිට මේ arrow එක නැතුවත් ගන්න පුළුවන් approximately, but we can't measure accurately, right? We can't measure accurately. To get the accurate extension measurements, yes, this answer. To get accurate extension measurement, that's a perfect answer. To get extension measurements accurately, we can ensure the accuracy by this indicator. Then calculate the cross-section area of the rubber strip normal to the tensile force. Normal to the tensile force, don't need. Calculate the cross-sectional area of the rubber strip. Okay, if you got the cross-sectional area, cross-section, how about the shape? Take a mono shape. Cross-section of the rubber strip. Yeah, it is rectangle. How about the shape? It is a rectangle like this. Okay, this is a cross-section. This is a cross-section. What is this length? It is 2 centimeter, right? 2 centimeter. And what is the width? 2 millimeter. Are you good? You good? The length, then if you cut, then cut karamani. This is a cross section. The width 2 centimeter and thickness 2 millimeter. The cross section is a rectangle. Understood? Okay, this is a cross section. Okay, now what is the area? What is the area? Just area asking, cross section area. 2 into 2. Correct? 2 into 2. 4. Met me? No, because 2 centimeter and 2 millimeter. You have to, better thing is you can convert into standard unit, right? The area equal 2 divided by 100, it is converted into meter. Multiplied by 2 divided by the thickness divided into 1000 to convert into meter. Now it is square meter. Now 2 over 1, 2, 3, 4, 5. This is the area 2 over 100,000. 2 over 100,000 mean 2 into 10 to the power minus 5 square meter. 2 into 10 to the power minus 5. 2 into 10 to the power minus 5. It is in standard unit. Standard unit. Now Vihanger, you have to convert into standard unit. The area standard unit, square meter. Square meter is the area standard unit. Okay, third one. If the extension of the rubber strip due to the tension force in the kite string is found to be 2 centimeter. That means the increasing length 2 centimeter, right? 2 centimeter. Calculate the tension force. Calculate the tension force. Young's module of this material of the rubber strip is 2 into 10 to the power minus 7. Not 7. 2 into 10 to the power 7 Nm minus 2. Yes, 4. Sorry. Okay. Now, this is the most important part and easy. See, you know the stress. Last week I explained the stress. The stress directly proportional to the strain according to Hooke's law. Stress mean F over A. Directly proportional to strain. Strain mean E over L1 extension over initial length. F over A, to equalize, we have to add a constant, that's the Young's module. That's the Young's module, E over L1. E over L1. I told last week, if I isolate this Young's module, if I isolate, it is F over A, that means stress over strain E over L1. E over L1. That's why I told the Young's module of any material equal to the what? Stress, the ratio between stress and strain. Remember, the ratio between stress and strain equal to the Young's module of any material. Young's module of any material. Young's module of any material. Okay, this is the equation. Now, you can substitute in this equation, right? Young's module equal F over A divided by E over L1. What is the Young's module? 2 into 10 to the power 7. 2 into 10 to the power 7. Nm minus 2. Nm minus 2 equal. What is the force? Tensile force is asking. Force tamahan. What's the cross section area? cross section area 4 into 10 to the power minus 5 that you already got. 4 into 10 to the power minus 5. ඒක අපි already ගත්ත කලින් නේද? Squared meter. Squared meter. Divide by extension 2 centimeters. 2 centimeters you have to convert into meter. It is 0.02. Multiply, not multiply, divide L1 40 centimeter. 40 centimeter means 0.04 meter. Not 0.04, 0.4 meter. Right? Meter to meter cancel out. Okay, now you can isolate F. That's all. Understood? Hari, F එක ගන්න. Vihanga, that's why we have to, previous part we have to get in meters, square meters. Then you can directly substitute. If not, again we have to convert. Okay, you can cross multiply first, right? Hari, කැල්ලෙන් හතර ගන්න. 0.02 divide 0.4 multiply by 2 into 10 to the power. It is 1 million, right? මේ ආටික මේ පැත්තෙන් multiply කරන්න. F over 4 into 10 to the power minus 5. F equal 40 Newton. Yes. Okay, very simple, right? You need only the basic knowledge of Young's module and mechanical properties of matters. Okay, the 40 Newton is the applied force. Note down. Okay, complete. Delete. Hari. Dinul, complete. Hari. Final one. It is not recommended to connect the kite string to the rubber strip through a hole piece at the upper end of the rubber strip. Explain the reason. ඇයි අපි මේකේ hole එකක් විදලා attach කරන්නේ නැත්තේ? It is attached by a supporter. What is the reason? What's the reason at the supporter? Actually, there are two possible reasons. Two possible reasons. Think practically and send your answer. Read again question and understand. It is not recommended to connect the kite string to the rubber strip through a hole piece at the upper end of the rubber strip. Explain the reason. Okay, can you say the force will be applied onto the attachment part only? Yeah, that's the one possibility. Yeah, if we applied only hole, if we attach by a hole, what happened? The one possibility, the force apply only, that we called the force not evenly distribute through string, not uniformly distribute. එතකොට මෙතනින් විතරයි නෙන්නේ. මේ ලේන් එකේ විතරයි. Force not evenly distribute. That's the one thing. Okay, what is the other practical thing? What is the other practical possibility? No, we can use indicator. Indicator තියනවා විහඟ. මෙන්න මේ මෙතන තියෙනවනේ ස්ට්‍රිප් එකක් දාලා අන්න එකයි නෑ කියලා කියන. Yes, it will be breakdown. ඒ hole එකෙන් තනින් මේක break වෙලා යන්න පුළුවන්. Breakdown the due to the higher stress, it will be breakdown. Yes, good, great. That's the reason. That's the reason. Okay, both answers correct. Both answers correct. Hi. Okay, understood. Any doubt? Okay. Okay, this question, it's a mark question number 10. Now I'm going to wind up today's session. Please mark this. Make a mark. Next week I'm going to discuss first this question. You can try this. Part B. It's a rotational motion question. As looking, it's very advanced question, like very complicated question, right? But it is questions very simple. You can see. Make a hadan. And now we have 10 minutes now. Make a hadan that pull. Wait. Okay. Any writing answer to explain this type question like that? So do we have to write quite long paragraphs or even short? No, no need long explanation. Essay type? No, no. You only need to answer short answer, but you have to mention all important point within your answer. Paragraphs the under ne කොහොමත් අපේ subject. In ET, I think ET and BST you have right, but in our paper no need paragraph questions. Within maximum 3 rules, you can explain the all important points you have to explain. If not, you can't get marks. That means you have to answer on into the point. Point එකටම දෙන්න ඕනේ answer එක. හරි අපි බලමු. දැන් මේවා calculations questions no worries. මේක explain කරන්න කියලා මොකුත් තිබ්බේ නැහැ. මේක තිබ්බේ නැහැ. Explain the reason for this. මේක දහන්න. Explain reason for this. Yeah. Only one rule. Only one line required. මේ බලන්නකෝ මේ අපි මාර්ක් ස්කීම් එක ආරම්භ බලමු. පෙට් මාර්කින් ලකුණු දීලා තියෙන කොහොමද බලමු. (2021) right? මේක නේ. Oh sorry. මේදී බලනවා. එකයි දීලා දෙන්නේ. ඉහළ පහත පිළිතුරු වලින් ඕනම එකක්. රබර් පටිය හරහා ආතති බලය සමානව පැතිරෙන්නේ නැත. මේ සිංහල මීඩියම් නේ. ඔච්චරයි මේක තමයි ආන්සර්. That's the explanation. මේ පොයින්ට්ස් තුනෙන් ඕනම එකකට හම්බ වෙනවා. හරිද? රබර් පටියේ සමස්ත හරස්කඩ වර්ගඵලයේ සපුර ලෙස දායක නොවේ. කියන්නේ අරකම තමයි. හරිද? රබර් පටිය ඉරී යාමට හෝ හානි වීමට ඉඩ ඇත. ඔය තුනෙන් ඔන්න ඔය විදිහට ලියුවම හරි. Understood? මේ ටික download කරගන්න සිංහලෙන් හරි ඔයාලට you can refer. I think I have upload 3 or 4 English medium pass මේ mark schemes. අනිත් ටික සිංහලෙන් ඇති. download කර. Okay, let's complete this one as. මේකත් ඉවර කරමු නේද? Okay, a light string wrapped around a pulley is pulled with a constant vertical force of 30 Newton as shown in the diagram. The moment of inertia of the pulley around the axis of rotation is 10⁻⁻⁴ kgm². the moment of inertia of the pulley around the axis of rotation, it is 2 into 10, that means I, right? Moment of inertia. Radius of pulley is 0.2 meters, that means 20 centimeters. Assume that pulley start from rest and string does not slip. String not slipping, right? Equations related to rotational motion are listed below. All equations ටිකක් දීලා තියෙනවා. හරි. Calculate the torque applied on the pulley. What's the torque? Torque equal FR. Simple. The applied force 30. 0.2 is a 6 Newton meter. 6 Newton meter. Write an equation to show the relationship among torque, moment, angular acceleration, and moment of inertia. Very simple. What is the relationship? Rho equal segment. I alpha, yes. Rho equal I alpha. Calculate the angular acceleration of the pulley. Calculate the angular acceleration of the pulley. Now, Rho already got. The moment of inertia given. Moment of inertia given. Now, Rho equal I alpha. Angular acceleration alpha is asking. The Rho equals 6 Newton meter. I 2 into 10 to the power minus 2. Alpha don't know. Alpha equal 6 over 2 into 10 to the power minus 2. It is 3. 300, no? RADS minus 2. 100 300 radians per square second. Radians per square second. 300 radians per square second. When, next one, when the pulley has rotated 25 turns. 25 turns. Again, 25 revolutions, right? Calculate the following. Angular displacement. Very simple. Within 25 revolution, angular displacement here. 50. 5 equal 3, no? Yes. Correct. Yeah. 55, correct. 55. Now 5 equal 3 kya dila thiyena. 5 equal 3 mean 150 radian. 150 radian. Angular velocity. Angular velocity. Angular velocity is a problem. We don't know time. Time then to කොහොමද velocity එකක්. How to calculate the angular velocity without time? Okay, try to get this. I can give you 1 minute. You can use above equations. උඩ දීලා තියෙන equations use කරන්න පුළුවන්. I found a method. I don't need to answer. Could you get some method? Okay, remember in rotational motion lesson, I explained about motion equations, right? I explained motion equation. In motion equation, we have only one equation without time. This equation omega squared equal omega naught squared plus 2 alpha theta. Make a equation. This is the only equation without time. Without time. Without time. Okay, I'm going to erase this. Okay. Omega squared we don't know. Omega naught squared. Omega naught squared mean initial angular velocity is 0 because it is starting from 0. It is starting from rest, right? Starting from rest. Then initial angular velocity 0. And 2, alpha you found. Alpha was 300. Theta, within 25 revolutions, it is 150. 150. Then omega squared equal, very careful, 2 into 150, 300, 300 into 300, 90,000. Now omega equal 90,000 square root. $300 R radius minus 1. Grade 0. You met? Understood? Priyanka? Dilip? It is 300 radians per square second. Kinetic energy. Now it is rotating. What is the kinetic energy type? Rotational kinetic energy. What is the equation? Half I omega square. Half I omega square. Easy. Half I, it is given the moment of inertia of the pulley given 2 into 10 to the power minus 2, right? Yes, 2 into 10 to the power minus 2. Omega squared. Omega squared mean 90,000, right? 300 squared. Now minus 2, 2 zeros cancel. 2 to 2 cancel. 900, correct? 900 joules, great. Nabil? Can you understand? Have complete these lessons, rotational motion, mechanical properties. ඒව කරලා තියෙනවද? Great. Then you can understand, right? Final one. By giving reasons or showing steps, calculate the work done by the 30 Newton force in rotating the pulley through 25 turns. What? By giving reasons or showing steps, calculate the work done by 30 Newton force in rotating the pulley through 25 turns. Now you can try. The question asks the work done by the pulley within 25 turns. Actually, no need calculation. The answer you all have answer now. Hurry. Try කරලා බලන්න. You can try now. Okay, what is the answer? How it's coming 942? Actually, answer 900. Why? Within 25 revolutions, the rotational kinetic energy 900. The pulley don't have any extra mechanical force, mechanical energy. It's only contain rotational kinetic energy. Don't have any potential energy or anything, right? It's not mentioned here. No any other energy stored. Therefore, the work done by the work you have to mention, but the reason clearly. Okay, that's the thing. That's it. By giving reasons or showing steps clearly. That's very important. The work done by pulley is equal to the rotational kinetic energy change or mechanical energy change. Rotational kinetic energy change or mechanical energy change. Okay, what is the rotational energy change? Rotational kinetic energy? The final kinetic. This one, tree. It is tree. Yeah, it is given phi equal tree. Yeah, the rotational kinetic energy, the pulley is starting from rest, then starting mechanical energy 0, starting rotational energy 0, final rotational kinetic energy 900, 900 minus 0. It's actually 900 joule is the final answer. These are work done by the object pulley within this 25 revolutions. Okay, but you have to clearly mention that, clearly show the steps. Understood, Vihanga? Okay, that's the end of 2021 paper questions. Next week, let's start 2015 to 16, 17, 18 කරගෙන යන් අපි area volume questions. Area volume trigonometry questions. And coordinate geometry also we can discuss after tomorrow exam. We have another more question. Next week we can discuss tomorrow paper. Tomorrow paper. Okay, let's see. After that, let's start area volume questions. Okay, now you can ready. You have time to ready. You have first question coordinate geometry and area volume. You need all equations. Equations, especially parallelogram, trapezium, all area and volume equations you need, and coordinate geometry equations you need. Then after that, work, mechanical properties, and force especially you have to go through again. Okay, then let's meet tomorrow morning. I will send you a link and join 8:30 p.m. I'm going to start the exam 9 a.m. Not p.m. a.m. morning. 8:30 a.m. Okay.